Okay, hello everyone. Let's go ahead and continue with matrix operations and definitions part 2, a continuation from the last lesson. Now what we're going to focus on is we're going to focus on multiplication of matrices, and we're going to look at the properties that apply and some of those that don't apply. Now let's go through the properties themselves. We have closure, commutative property, zero matrix multiplication, distribution, the multiplicative identity matrix, as well as matrix powers. Now, with closure, basically what we're asking is if you can actually multiply two matrices together, let's call these matrices A and B, will the result have to be a matrix? Or in other words, can the result be something other than a matrix? Well, we know for a fact that since A times B are two matrices that can be multiplied together, the result will have to be another matrix. Therefore, we know that matrix multiplication is closed. Okay, and the property of closure applies. Now, when we talked about the commutative property, what we're basically asking is AB equal to BA? And we know for a fact from previous studies that we've had that that is not true. Let's go ahead and take a look at matrix multiplication. Matrix multiplication says if you have the zero matrix, which is of course a matrix that will have all elements being equal to 0. If you take that zero matrix and right multiply it to A, and if you take that zero matrix and left multiply it to A, will you still come out with the zero matrix? And the answer, of course, for that will be yes, because all of the elements in the zero matrix is 0. Okay, now the distribution law will also work for both of these examples here, and notice that again we have to pay attention to whether we are multiplying A to the left of B plus C or multiplying A to the right of B plus C, and notice that there is a difference in the way that you write that because the property of being commutative does not apply for matrix multiplication. Now with the multiplicative identity matrix, we have the I being equal to 1, 0, 0, 1 for our 2 by 2 matrix. And notice that if we take I and right multiply to A or left multiply to A, you will still come out with the value of the matrix A. So that's what the multiplicative identity matrix will do for you. Now when it comes to matrix powers, it will only be possible for integral powers and square matrices. So in other words, you need to have a square matrix raised to an integer power in order to actually perform that matrix power operation. Now, when we actually get into class, we'll go ahead and take a look at the proofs, and the proofs for some of these are in the exercises that we'll have. So it'll be easier if we go ahead and do that in class together. Now, we do want to go ahead though and be able to apply these rules of matrices and these properties of matrices, matrix multiplication, to a particular problem that deal with matrices and the operations. So let's go ahead and take a look at, let's assume that all matrices are 2 by 2, and we also know that the identity matrix is of course this matrix here. So if I go ahead and take a look at the quantity 3i minus b, raised it to the second power, then what I need to do is I need to expand this by saying that that's just going to be 3i minus b times by 3i minus b. Then I'm going to have to make a decision as to how I want to go about distributing the 3i minus b to the 3i minus b. So what I'm going to do is I'm going to take this 3i minus b here, and being that that's left multiplied to this 3i minus b here, I'm going to distribute while at the same time maintaining the fact that I'm left multiplying. So what I have here is 3i minus b being left multiplied to 3i minus the left multiplication of 3i minus b to b. Now again, I'm going to have to still maintain the fact that I'm right multiplying this time 3i to the 3i minus b, so notice that's where the 3i is. And I'm also right multiplying b to the 3i minus b here, and notice I've also distributed the sign. So what I have now is if I multiply these two together, that's going to be 9i squared. minus the 3bi. Notice again that the b and the I are in the correct order. And then this here is going to be minus 3ib. Notice the correct order again. And then plus b squared. So now that I know that I, which is of course the identity matrix, times it by itself is still just going to be I. So I can simplify that to just 9i. This is going to be simplified to 3b because b multiplied by the identity matrix is just going to be b. Same thing here, except same thing here. And notice that this is just going to be b squared. So I can come up with a simplified form of this expansion to say 9i minus 6b plus b squared. Okay, so we'll go ahead and take a look at further examples in class as to how to apply the matrix multiplication properties to particular algebraic expressions using matrices. Okay, so give it your best shot, and we'll also go ahead and take a look at some of the proofs as well for some of these properties. Okay? Give it your best shot, and see you next time. Bye.